Hello and welcome back to Faceless Security, where we explore the world of technology and cybersecurity.
All right, let's get into it. We're going to pull back the curtain on a world you probably never think about, but one that powers, well, everything. We're talking about the huge, complex, and absolutely vital world of operational technology. You'll hear it called OT. So think about this for a second. What's actually making the lights turn on? What's getting clean water to your house? Or making sure the factories that build everything are, actually running? The answer is pretty fascinating, and maybe not what you'd expect. Yeah, this isn't your typical IT department with servers and emails and all that. This is something totally different. This is operational technology. It's the stuff that makes the physical worlds go round. The hardware and software that are actually touching, monitoring, and controlling real-world things.
All right, so let's break this down. For the longest time, IT, information technology, and OT were two completely separate universes. I mean, they didn't mix at all, like oil and water, but that's all changing. These two worlds are colliding, and that's creating some amazing new possibilities, but it's also opening up a whole new can of worms when it comes to risk.
So what's the real difference here? Well, think of it like this. IT is all about data, digital stuff, servers, emails, websites, that's the IT world. But OT? OT is all about physics. It's the tech that actually makes things happen in the real world. It tells a valve to open, a motor to start, or a factory robot to do its job. It's where the digital world touches the physical one.
And here's where it gets really, really interesting. Because they do such different things, they have completely different priorities. I mean, what's important to an IT team is almost the exact opposite of what's important in an OT environment. They're just wired differently.
Just look at this table. It spells out that clash perfectly. IT is all about protecting data, confidentiality, integrity. That's their game. But OT, their main goal is availability and safety, keeping things running and keeping people safe. I mean, think about it. If the IT network goes down, you can't get your email. Annoying, right? But if an OT network at a power plant goes down, an entire city could lose electricity. And check out those life cycles. IT gear gets swapped out every 3 to 5 years. OT equipment? It's built to last for 20 years or more. Imagine trying to update software on a 20-year-old machine.
This really gets to the core of it. In the IT world, security is all about the CIA triad: confidentiality, integrity, and availability. Keeping data secret is number one. But in OT, they flip that completely on its head. It's AIC. Availability is king. The system cannot go down, period. Then comes integrity, because you have to trust the commands being sent. And confidentiality? Well, it's important, but it's often a distant third.
Okay, so we get the why. Now let's talk about the what. What does one of these OT environments actually look like? What are the bits and pieces that make all this physical stuff happen? Let's take a look inside the world of industrial controls. So OT is the big picture term for all this tech. And under that umbrella, you'll find something called Industrial Control Systems, or ICS. These are the actual systems, the computers, the networks, the software that people use to run everything from a factory floor to an entire power grid. And inside these systems, you find the real workhorses. You've got things like PLCs and RTUs. Think of these as the rugged little brains of the operation. Then you have HMIs, which are basically the screens the operators look at to see what the heck is going on. And then you have the sensors and actuators. They're the eyes, ears, and hands of the whole setup, the parts that are physically sensing things and making things move. Let's focus on the PLC for a second, because this thing is basically the heart of all modern automation. Just think of it as a super tough little industrial computer. Its job is simple but critical. It reads an input, like "this tank is full," and then it executes a command, like "turn off the pump." It's built to just sit there in a hot, dusty factory and do its one job perfectly 24/7 for decades. Okay, so let's put it all together with a real-world example. Check out this diagram of a water treatment plant. You can see the PLCs, those little brains, at the bottom. They're connected to sensors, that's the S, which are feeding them information. Based on that info, they send commands out to the actuators, that's the A, to actually do something, like open a valve. And all of that is connected to the network, so an operator, sitting at their HMI screen, can see and control the whole shebang. Now, here's a super important point. These industrial gadgets don't speak the same language as your laptop or your phone. They have their own special languages, called industrial protocols. And a lot of these languages were invented decades ago, way before anyone was even thinking about cybersecurity.
And here are some of the big ones. You'll hear names like Modbus, DNP3, CIP. These are the languages that make everything on the factory floor talk to each other. They're super efficient, super reliable, but they were all created with one massive assumption, that the network they were on would be completely cut off from the rest of the world.
Let's just take Modbus. It's a perfect example. It's one of the oldest, most common protocols still used today. We're talking created back in the 1970s. And the most important thing to know about it is that it's what we call insecure by design. Security wasn't even a feature. It was never, ever meant to be on a network that could be attacked.
And that's the whole problem right there. See, when these protocols were invented, the networks were air-gapped, physically disconnected from everything else. The goal was to make them fast and simple, not secure. So they don't have basic things like encryption or any way to check who's sending a command. Literally, any device on the network can tell a PLC what to do, and the PLC just does it. No questions asked. That was totally fine when the network was a closed box, but today, that's a massive, gaping security hole.
So, this is where we are now. This is the big challenge. What happens when you take the fast-moving IT world, which is all about security and updates, and you smash it together with the slow-moving OT world, which is all about safety, uptime, and technology that's decades old?
Well, what happens is you get what we call a much bigger attack surface. By connecting these old, isolated industrial networks to the main company network, and sometimes even to the internet, we're basically opening a door. We're showing a whole world of new threats to these old systems that were never, ever designed to defend themselves.
And the stakes here are just incredibly high. There's a quote that really hits this home. It says something like, "A compromise in IT might expose information, but a compromise in OT can stop production, damage machinery, or put people's safety at risk." It's not just about losing data anymore. It's about physical, real-world consequences.
And that's really the big question we're all facing now, isn't it? As our digital and physical worlds keep merging into one, how do we protect both? It's not just about protecting our data anymore, and it's not just about protecting machines. It's about protecting the whole connected system that we all depend on.
Thank you for watching. Be sure to like, comment, and subscribe for more great content from Faceless Security.